things that are divisible by seven, which is always my favorite kind of month. We'll see. I think we had a divisible by seven run earlier this year that lasted almost 2 months. So the 7th, 14th, 21st, and so on. So let's see how long that lasts. I might be the only person in the world that even cares about if it's divisible by seven, but here we are, November 7th. It's going to snow this weekend, apparently, in Toronto. I hear for the metric crew, what did they say, 10 to 15 centimeters, which is like a billion inches, I guess. So
Mhm.
there you go. It should be an exciting weekend for those who like snow anyway here in Canada. Rob, what's happening? Who do we get lined up today?
Excuse me.
Oh, you're
Yeah,
you're 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 nice and blurry too.
am I nice and blurry? Yeah, that's right. We just moved out into the country, and it's not much of a connection yet. So I've got the high-speed internet coming over the next week or so. So maybe a little pixelated as we're going. We've got today. We've got the Paris chapter. Vincent, Arsene, and Jean-Marie have been working with TV5 in France. And between TV5 and Monde Plus, they represent about 400 million global subscribers. And they are putting together a hackathon. So the Genix Foundation, they're going to table what that might look like and some ideas around the structure and the opportunity of what that hackathon could represent and the challenge that the industry as a whole and TV5 is looking to solve. So um, had a chance to have some pretty interesting conversations a little earlier, and the Paris chapter is going to be tabling what this will look like for the foundation today. So, and there's lots of really interesting aspects to discuss. So, we've got a little bit of room to do that as well. So, it should be really interesting.
Well, yeah, we had the French crew on last week, so that was pretty exciting, and lots going on with Vincent and the crew in Paris. So yeah, I'm excited to see what's happening, and we've got an event that we've been busy organizing for Tokyo in about a month. That I see. I won't be able to make the call tonight, but I see there's a call to discuss this evening. How's that coming along?
Good. December 3rd. And we have a new ambassador out of Norway that's actually going to be in Japan at the same time. So it's perfect there. Ken, our chair of legal, is going to be traveling to Japan for that event, and with some really notable folks that are going to be speaking there for that kickoff. So yeah, that's going to be really interesting to see how that all comes together. Of course, with the
Yeah.
partnership of 42 as well. So it'll be hosted at 42 in Tokyo.
Okay. Great. And I promised the last update on baseball for this year and possibly for the next 32 years. The Blue Jays lost. It was a bit of a disappointing moment for Canadian pride. What can we do? We'll have to make it up next decade or something. Oh well.
That's right. It
What
was
can
a
you?
really enjoyable run for sure. Anthony
Yeah.
or Clement was incredible. Some great players, but it's hockey season, Roof. So
That's not. Yeah. Well, it's agentic season. Who got time to
agentic
watch
season.
that?
There we go. There we
Yeah.
go.
Yeah. Anyway, been busy this week building lots of stuff as always, and I get a lot of pushback on the lack of UIs and so I've taken it upon myself to attempt to build some UIs, mostly just to prove that I can build UIs. And so that's been some of the things. I'll show you some of the UIs I'm building. And of course, when I built the UI, I built it directly into my website. So there's going to be, and now I got to figure out how to sort of take it from the website and make it available to everybody else. But that's a secondary problem. The first problem was just showing you that it was possible. But before we do, what's do we have room for some folks that want to show? I think there's a few people who reached out that said they wanted to do some demos later as well. So, if you do, let us know in the chat, and you can show what you got. I'm sure there's a few different potential demonstrations we can take on here today. Yeah, what am I forgetting, Rob? Anything?
No, I think that's good. Dragan has a demo he's going to show with us a little later on, and Oh, we're good to go. Let's dive in.
All right, let's see here. I got a new system, so I gotta make sure I share the right screen. Let's go with Research Swarm. It seems like ages ago, which was Monday, that I put this out. And a lot of the things that I'm building are built on top. One thing builds on the next, builds on the other. And when you look at these systems, you know, you're getting a feel for kind of this modular architecture that I'm using. And here, let me just show you. So I got these projects. You got Agent DB, and I've got these various, various modular components that kind of plug and play like a kind of Lego building block. Now, when you think of the things that I'm building, remember that I'm building them using this combination of a Rust-based kind of logic. So I use the Rust because it's really good at building things without it going off into the weeds in the wrong location. It's super fast and efficient. But the problem with Rust is nobody uses it beyond sort of the core, and it takes a while to compile. So I compile these to what they call a WebAssembly or WASM, and then I distributed them as an NPM. And so you'll see there's a number of different components here I have, and for whatever reason, I'm getting downloaded limited errors here, but whatever. And then that allows me to use these components both in Node and TypeScript, but also easily make them available in if for like within the browser or other environments. So the research swarm is a perfect example. This one takes a combination of the agentic swarm system that I've built and the agent DB system, and basically shows you how it works. So a few weeks ago, you probably remember my goalie system. The goalie system uses the GOPS concept of goal oriented action planning. For those who are not familiar with the concept, that's from video games. If you've ever used an NPM in some of the more modern video games, or an no, sorry, MCP. I get NPM on my mind here. A non-playable character. A lot of the non-playable characters use the idea of goal-oriented action planning. That means they're given broadly the description of what and how they need to interact within the gameplay, but beyond that, they're adaptive, right? So conceptually, the concepts of creating something that is adaptive and can alter and learn and change based on how it's interacted with is an important part of it. And it works particularly well for agents and research systems in particular. So to help illustrate that a little bit, of course my UI looks like a console because it had to be done. So in this case, you can go in here and you can define your research goal. I create a little AI generator here that helps you do that and create some examples. Now, whenever you're looking at my systems, you can always take a look at the console. The console here, I build, and I can see this is the Root console. Let's do help. You can see all my commands. I'm using this as a way to help me debug, and it's just super nerdy, so why not? So there's two parts. So in this case, we can go here and we can do research for my PhD. I'm just making it up. We'll do social sciences. Then we can see different options here relating to the length or the focus point, specific comparative trends, that sort of thing. And this is meant to be illustrative of how you can build these kind of research agents. And the other thing I'm going to point out with the research swarm implementation, this is meant to essentially run forever. And when you're building, I didn't run it forever because it would cost me a fortune to have to pay for all you guys running this forever. But so I may only make this run for like 2 minutes. But basically, the idea is these agents can run perpetually, getting information, learning, adapting, and taking the things that they learn and then using it for certain things. So, for example, I might have my agent working to optimize my ad campaign. And as people buy stuff on my website, it'll learn and adjust based on what others are doing, and then maybe optimize based on what it's learned for certain demographics, certain things that convert better, that kind of thing. In this case, I'm just using for research. So I've got different tones, I've got different lengths of time. I'm going to go with the Chicago style. Why not? I didn't even know Chicago style was even a citation style until the system told me. But yeah, you can do different styles. Actually, I'm gonna do Harvard style for Brad, since Brad's been doing his master's over at Harvard. and I can choose the structure and the verification. So the verification is particularly important, especially if you're doing things that require a grounding. So again, using the ED255 verification framework, I can choose the level for verification here. And this particular one, I'm using Google because it's cheap and fast, that kind of thing. And then my swarm, I can crank up the amount of the agents, that kind of thing. Self-learning, perpetual. I turn that off. So this currently doesn't do anything because I'm not paying for that. And so then let's execute it. Now over here, we're going to keep an eye on two different things. So over on the right-hand side, this is the browser console. Over in the middle, this is essentially the requests that I'm making. Now, when you look here, you can see how I'm making the request, and I make these sort of visible so you can see exactly how the thing works. Now, it's going to take a second for it to sort of do its thing. We can see here it's going and doing the AI processing. Now, I probably could have created a multi-step view for it to sort of do its research. But in this, yeah, that would have cost more as well. So instead, I'm sort of just showing you as it returns here. So we're seeing that my different agents are spawning the different actions. Phase one, initial discovery. We're seeing that it's doing starting, it's doing analysis. It's just a more intelligent version of like ChatGPT's deep research. You can see it's finding citations. It's more recursive. It's more self-capable. It just adapts more. One of the drawbacks when you use like Claude or Gemini's deep learning system is it has a tendency to be fairly sequential in how it discovers things, and it doesn't sort of have this level of self-reflection. All right, it looks like that actually finished, I think. So let's go. Now we can go here to agent flow. This shows me a nice little diagram. And by the way, if you're looking to do diagrams, which apparently everyone is, this diagram is actually using something called React Flow. So if you're looking to do these drag and drop sort of diagrams, this is a nice way to do it. You can see the findings. I didn't really do much of a researcher. I said to do a PhD research for my PhD, but I didn't actually tell it particularly what to research for. So this was kind of a last second find here. You can see I structure it in analysis. Here are the citations. These are the groundings. So you can see the Harvard style that was done. It looks like it specifically looked for Harvard related research in this case. Example.com looks a little problematic. I got to take a look at what that is. You never want to see example.com, so maybe I have to do a little more digging there. Anyway, and then you've got five-phase recursive framework, and this is doing basically the validation. This is a one-off, so the learning is limited because I literally just did one sort of view, and I'm not sharing the previous learnings in this case. I'm just basically doing it within the structure of the browser. So as soon as I hit refresh on this page, any of the learnings would be lost because I'm not actually there's no persistence. But it does show you that it's capable of doing those things. Now, for persistence, you'd want to save it to a database somewhere. I'm going to show you one more thing. I know I don't have a lot of time, so I'm just going to show you one more thing. The next thing I have is in the what I call it, agentic flow, and I've done some major updates to agentic flow this week, and thanks for everyone for helping debug that, including the proxy capability, which fingers crossed, Peter's been helping me fix. I just pushed an update there that allows you to basically use Claude Code or these Claude agent SDK with alternate providers other than Claude itself. So you can use Gemini, hopefully, and Open Router. But I also included a little demo here to show you all the various options. So in this case, if I choose, let's do something else. Let's go with, I don't know, neural training. We'll do SAFLA. And now if I click the generate, this will actually generate a nice big task. You can see I've got different models available here, different prioritizations. So what I'm showing you here is all the various options available to the system, and actually not all of them, most of them, and how you can sort of configure them. So this is meant to be basically a visual demonstration of the system. The federation capabilities is pretty cool. I've been working through that. Might be some bugs, according to Peter, I might need to fix there. But basically, the federation option allows you to create a distributed global group of agents that are spread out across the world if in a kind of temporary or ephemeral environment, and then they can collaborate with each other using a sort of core coordinator, which is kind of a cool feature. The quick feature allows for high-speed interchange between them. So let's say you're creating a trading bot or something and you need them to be able to do millisecond trades, and you'd probably want to use this capability. This is for the more technical folks in the audience. This is a specification from Google that's based on the UDP specification. Local Onyx essentially is using your own local model versus remotes. This is super cheap, no external resources. Reasoning banks, decision transformers. This is the learning structure. So I got lots of different learning. I generally use the decision transformer here. Memory and caching. This is the various forms of the memory bank itself. So how the memory itself is sort of adapting and learning to what it needs to know. So I generally choose this adaptive version, the ML based, but you can do least recent, least, the least frequent, time based. You'd have to play with it to figure out what the most optimal sort of strategy is. And depending on the application, you're going to change the memory structure. For example, coding is going to be a little bit different than like in a trading bot. So sometimes you might just say deploy all five different versions and tell me which one solves my problem the best. It's going to take a little bit of trial and error, most likely. Retries and handling. So what this does is essentially says AI models sometimes fail, especially if you're using local models or if you're using the free models from Open Router. So what this essentially does is allows you to connect all the various free models and then just essentially say cascade through the free models based on what performs the best kind of thing. All right, so I'm going to go ahead and just do that. So I'm going to go to execution. I'm going to execute. Now, again, you can see here. We can also hopefully see, I don't know if I spend as much time on the console here. We'll see. This is the last thing I built this week, so we'll see. It's coordinating. I also slapped in a quick little visualization just to show how that works. Now this whole thing takes a minute to run. But again, this is unlike the Agent DB demos I showed you guys that was a week ago. This isn't running purely in your browser. This is actually using a combination of edge services. Actually, I'm using Supabase edge functions to do that, and then coordinate it in the browser itself. But it does show you that it is possible, and not everything. Even though I made it look like a CLI, I guess not everything has to be a CLI. Let me pause for a moment. You guys have any questions so far on my rant here?
Yeah, Roof, I have a question about the previous thing you showed, that research thingy.
Yeah.
So you use this, like you have this drop down for different citation styles, so like Harvard, IEEE, where else, like Chicago. Usually, when people write sort of published work, right? I mean, if you're using LaTeX, it's an option there. So you maintain all your references in like a database, and there is an option like what style you want to use, like, and it's usually just like it pulls the template and it formats its automatic thing. So you might be just overwhelming your models with overthinking because all the sort of publishing software just it's just a little button there essentially too. But what you need to
Yeah.
maintain is the database of references.
Yeah, and to be honest, most of this is stored within the reasoning bank structure
Yeah.
and then correlated. What I'm showing you isn't necessary. Like the other day was it? I don't
Yeah.
remember. Was it gold root? I don't remember what the URL
Uh-huh.
was. But the one no yeah this goal oriented action planning
Uh-huh.
demo I did the other day is probably better suited for most types of kind of
Okay.
real-time research, where what I was trying to illustrate on this one, but doing probably a not great job, was like
Hmm.
how does it work over an extended period of time? I guess
Oh,
long
I see.
horizon. Um,
Yeah.
where this is more like,
You're still using a
res
swan in goal, a goalie
Yeah,
basically.
but for the so basically for grounding and references, like both Google, like you want to keep them in the BibTeX format, and both Google Scholar and Archive, like all the big platforms, they just give you the references and the database records, and you can just dump them. And I know Claude is very good at that, like basically understanding the structure, like citing them, understanding the model, because it's been around since like 1973 or something.
yeah. So it's It depends what you're trying to do, but like I would say half of all agentic projects involve some form of like research. At least there's a
Hmm.
research phase as part of the process. And what I'm trying to show is like the research doesn't need to be a moment in time, but it can be an ongoing process. What you're looking at right now, is kind of like a moment in time. Like it's doing really good deep research on this case,
Hmm.
CRISPR-based gene editing or something, but the question is, if the data changes next week, is the system smart enough to automatically detect that there's new research and then learn what that research means and then use it as part of whatever it's doing? That's what this goal
Hmm.
system doesn't do. It doesn't learn and adapt. It just
Hmm.
kind of does the research and then says, here's the result. Kind of like
So
using Claude
Yeah.
code.
I'm guessing you are trying to integrate the other one into Midstreamer for like ongoing adaptation of the agents based on.
Exactly.
So,
And that's what you're seeing here. So
yeah.
it's supposed to stream introspection. Like, here's all the information flowing to and from the system. What can I get and understand
Yeah.
from it? That kind of thing.
Yeah. So for updating, so I probably should look at Google Scholar because you can basically, I know if you're like a person, it watches like what you sort of retrieve and it sends you email once a week says like, hey, there is a new like articles from this.
Yeah.
And you can just subscribe. You can follow specific like research groups, like authors, like on the keyboard, like you can. And I think there is a even like it's a long time ago the back in LangChain days, there was a like a LangChain has a tool for the Google Scholar. It's been
Yeah.
around.
And to be honest, I'm not necessarily pointing out the fact that these things don't
Mm.
already exist somewhere or somehow. I'm just
No,
more curious on how to build them
yeah,
and
they
trying to.
yeah. So whatever you showed, it doesn't exist. I'm just saying they're like this very old tools that you can get research information like just besides the like web scraping. I mean, it's still web scraping, but it's a little bit more like civilized version of web scraping.
Yeah, there's a question in regards to how do I stay on goal if the goal can change depending on the research. That
Yeah.
is the fundamental problem with declarative systems. Now, it depends on the optimal outcome. So if the optimal outcome of the system, let's just use an example of stock trading because it's easy. If the optimal outcome of the system is to make a positive return, make more money than you spend, then the system is going to be learning how to adapt based on the information. And then I'm giving it enough, I don't know, rope to go and do various types of analysis. And that doesn't necessarily involve actually trading. It might be paper trading and doing sort of secondary trading to understand the ramifications of those trades over an extended period of time, a week or a month, and then learn what works and what doesn't. And then when a certain threshold is met, one of two things might happen. Because it's an agent, it might just send me an email, or in my case, I like using Slack and other types of interfaces and say, should I do this trade? Now, the problem with the should I do this trade thing, and I've noticed when I get it to tell me I used a lot of crypto for it because crypto is easy and cheap, but by the time it's asked me to do should I do the trade, generally the window of opportunity is already passed. So I'm like, yeah, go do that trade. And the response will be, oh, we should have done it 2 hours ago. Right. And I just never got around to it. So it's like the self-driving car analogy that I've been using lately. It's like the first time you're in like a Tesla and you're set it on autopilot, you're just kind of holding the wheel even though it's driving for you because you don't really trust it. Takes a while for you to trust that the thing's going to do what it's supposed to do and it's not going to go off and do some terrible thing and lose all your money kind of thing. And that just takes time and confidence. So there is no real easy answer other than you need to be confident in the system you built will do what you want it to do.
So I assume that then what it means is the goal needs to have to be clear enough that it doesn't really change. So in your case, in the trading, it will be that you want to make a benefit. If the goal is abstract, then I'm not explaining myself properly,
Yeah,
but yeah,
you
I
no
think
no
we get the idea.
No, you're exactly right. It's the more narrow the goal, the more likely it is you hit the goal. And you see that a lot in the sort of temporal elements of these systems. And when I mean temporal, I mean time constrained agents. And when you have a very small window and very tight deliverable within that window, you need to do this particular thing and you need to do it as fast as you possibly can. You are able to get to that result more quickly and more efficiently and repeatably because it's constrained. The constraints are what make agents work. When you make broad sort of deliverables, go figure it out and tell me what the optimal result is or whatever. It may work depending on what you're doing, but generally speaking, it doesn't know and it takes you in wrong path. So yeah, the more narrow the agent, the more narrow the path, and the more clearly defined it is, which seems obvious, the better the agent works. And this is obvious. It seemed almost obvious when I say it, but yeah, narrow, high speed, and frequent. Those are the things that I'm doing. Yeah, yeah. Doug's Ford example. I don't know if I trust a Ford self-driving Ford, but good luck. I live in Oakville, Ontario, by the way, where we have the big Ford dealership. So my neighborhood is basically nothing but Fords. Well, and I like the Fords that have the weird colors before they release them that you can't tell it's a Mustang because it's got some kind of crazy color scheme on it, but it's obviously a Mustang. All right, I digress. How we doing here? Who's up next, Rob?
We're good. Excuse me. Um, why don't we dive in with Vincent, Arsene, and Jean-Marie? Vincent, you there?
Yes, yes, I'm here.
Hey, welcome. It was
Hi, everyone.
congratulations on last week's event.
Thank you. That was great. Let me share the behind the scene. I'm gonna quick video, 30-second video, 20-second video. So do you see the screen? This is can you see it?
Yes.
Yeah. So that's école 40, that's école 42, not 42, sorry for the French. And the lady here is Melanie, so she's the one that made it possible. We were supposed to have, we had about 50 people. Was supposed to be 4 times that, but apparently they had a heavy drinking night the night before. It was Halloween. So we
It
only,
happens in Paris.
my God, Paris was just crazy. I have other videos to show you, but if above 18. Anyway, so about 40, 50 people came, and we were very lucky to have two major actors in their fields. The CEO of TV5 World, or in French, TV5 Monde, which I've just learned you have actually a TV5 Quebec thing, or TV5 Canada. I didn't know. So it's a consortium of different states, including Canada. Now I know, and it represents about 400 million viewers. It's the second largest TV network in the world. So that guy came to talk about the challenge of being a media in a world where search happens more and more within AI, right? So he took us through that journey, and then we had the CEO of Provence Tourism. I think I've mentioned it last time. I'm repeating myself. I'm getting old. And she also addressed the same issues, really. Like what's going to happen for tourism brand when people search on ChatGPT? And already they noticed a lot of loss of traffic already. Long story short, this became a conversation about why don't we join forces? Why don't we explore your problems and try to find solutions for the problems? And the name here is a hackathon, right? And of course, everyone became excited. Yeah, let's do a hackathon. Da, 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 da. And so the TV5 CEO, Patrice, said, well, my problems are discoverability, too much content. And for the user, the end user, it's the time spent to find content. On average, people spend 40 minutes to find content to watch every night. So that's way too long. And they end up not watching nothing because they've just no energy anymore to watch stuff. So we have this problem, this perfect storm of too much content, and you can't actually find what you want, right? And so we kind of handshake. Okay, let's do a French hackathon on that problem together in December. And over the weekend, it occurred to me that was the wrong way to approach things. It should not be a French thing. It should be a global thing. It should be all of us joining forces all of the chapters, all of the headquarters in Canada, and together we address that problem. So that was the first kind of a lightning strike of, yeah, let's change the method a little bit here. But the second thing that really struck a chord with me was a chat with Jean-Marie and Arsène. Because we have two ways to do hackathon, right? We have the competitive way. Hey, show me what show me your best ideas and the winner takes all type approach. It doesn't really match the values of Agentics. And that's personally, that's why I'm part of Agentics, because I love the values. Every time that Rob, you share your values, and Rob and others, it resonates. So I thought to myself, and Jean-Marie and Arsène agreed, let's make it a collaborative global hackathon, like an open source hackathon. So instead of trying to compete against each other, let's address that big problem together, and let's try to build an MVP to bring us a solution, right? But by joining forces, we should get something pretty impressive at a world level, at the global level. And so the idea that came forward was TV5 become like a sponsor, so they're going to allocate some fund to this, right? And if we deliver, then the funds are unlocked. If we don't deliver, then they pay nothing. So we become a POC factory, an MVP factory. And it starts with TV5. Then we have the Provence Tourism Board. And then the idea is to get more and more global brands to join the party. And so the idea is to create impact and to be recognized as the MVP factory for global brands. That's the idea here. And so how do we pull that off is a topic we've just discussed an hour ago with Rob Branson and Robert Ye and Jed and others to make it happen. But that's what is on offer today for us, is to show impact, to show to the world that there is a way to collaborate and to do things at global level that will impact the world. And for us at individual level, it's about three things, you know. We all want to learn, to build, and to earn. That's the chance. That's the chance. So that's what we want to propose. The second thing that I want to mention is actually Jean-Marie is going to take over here for me. Let's do it in a very clever way. And I'm inspired by Roove and its marketing. Let's brand that. You know, we already have a powerful brand, Agentics, right? We consider to be probably the largest open source media influencer around AI Agentics in the world. But let's make it a brand, almost like you know, the opposite of Anonymous. You know, they have a mask and they have color scheme and so on. Same, but the good guys. And so when we do hackathon and their live stream and so on, we all dress the same. I'm going to let Jean-Marie explain, because just before I introduce Jean-Marie, remember, he's the guy that was managing Daft Punk digital presence, right? He's the guy that launched the Google Pixel in France. He's the guy that works with L'Oréal and Channel. He knows communication, he knows PR. So Jean-Marie, if you want to give a little bit more insight in your thinking here.
Well, thank you so much, Vincent, and everybody. So yes, I may be the one that is the more advertising expert here, and surely the less multi-agent expert. So I'm very proud and happy to be with you guys and surrounded by all these experts. It's kind of a dream for me. I've been like dreaming of this global hackathon for 2 years before I knew you guys, because I envisioned this 2 years ago, that if we could put globally people on one subject, not in competition, but in together to solve problems, this could be an alternative way to solve big problems. It's a framework that only the open source can bring, because in other models you need to pay people to make them work. So this is different. So today we have an opportunity to make this happen, and it's incredible. And of course, the first ideas that come to me is of branding, is like, because this is a superpower. Just all these people together tonight in a Zoom, it's a superpower. And of course, if we could all be like Rev with an agentic logo in the same all together, we literally would look like an army or a superpower. So the anonymous example is good one, even if it's the opposite that we want to bring, because we want to bring a positive image and like the white force. But if we brainstorm about the PR opportunity of this global hackathon, I think it's literally one big. If I think about this from the outside, I would be like almost scared about kind of transversal global open source superpower that can activate themselves into common shared goals and produce on a global scale prototypes. So how could we leverage that a little more by having kind of a hackathon, global hackathon branding or positioning? We brought a lot of ID. Maybe they are a little too. Maybe we go too far. We wanted to share that with you and to see what we should do next. But yeah, that's the main idea.
And what types of applications do you see us building?
Okay. So I'm going to take over now. The prime statement from the TV5 CEO is people spend way too much time trying to find content, and our content is not being seen. So he was not selfish in his approach. He was like, at a minimum, I would like to be able to know what's trending on Netflix, Disney Plus, Prime, and what I should watch. So this is not unrealistic. It just happened that I came across this app built by some French guy actually. Let me just share my screen for a minute. And he actually cracked it as an app. So it's a Tinder style application where you basically give data about what you like, what you don't like, And the more you give feedback, the better. It's already connected. I don't know how he did it, but it's already connected to Apple TV Plus, Amazon Prime, Netflix. So you step one, you Tinder style what you like, what you don't like. Step two, okay, tonight this is what's trending that you should watch. Boom. So this makes me send me the signal. This is possible. I'm not sure this is the way it should be delivered. I'm not sure it should be an app on the App Store. I envision this to be much more agentic. But that's more or less what Patrice has in mind. It's a solution like this, which seems realistic given that it's already something on the App Store. Not very old though. It's like a few weeks old, but yeah.
So I think just to abstract it a little bit, the thinking was, I mean, recommendation engines exist many places. Netflix has, Google TV, for example, has done a good job where when I look at my app on Google TV, it brings in Prime, G5, and everything together. But that still is like a section of digital content. But my digital life goes beyond that. Like I might like to read, and this is going a little bit off tangent probably, so I tend to be stopped here. But print, for example, like I do other things. I go on Instagram, I do other things. But as an individual, when I'm out and about, can I find content that is really relevant straight away? Right? That is like culturally sensitive, legally sensitive, but I'm not like I can relate to this point. Like when I go to Netflix, when I'm searching, like I've watched everything, what else can I watch? So it's to probably allow the digital content to be more. You could even think of print as well, right? Harvard Business Reviews, or you can think about economists, like there was an economist hackathon. They also have content. So that might be relevant, but there may be something in that TV Monday provides that is very relevant at what I was reading in The Economist. But can I kind of dig into that more easily? I think it's that. That's that kind of Vincent, yeah. Jean-Marie Arsen.
Yes, it's so the sources extend beyond the usual suspects, even though they are important. I just want to comment on the chat question right now about why should we help TV5 more, which is a commercial endeavor with millions of viewers. Well, helping them help us, because basically we are offered the opportunity to deliver impact at global scale and to get something started here, to put the wheels in motion, to become recognized as the platform where brands should go to test their assumption, their hypothesis, and build proof of concept. And of course, there is going to be a value exchange. So, okay, you have to allocate a little bit of funding. If we deliver, everybody gets incentivized on the delivery, right? So initially it's going to be peanuts, but as we progress, it's going to become important. And moreover, it's going to give us visibility on the market. So it's not really about helping TV5 or others. It's about how together we help each other. That's the simplest reply.
Yeah, I'm involved in a lot of hackathons recently with the work I'm doing with several universities. And a lot of the students are using hackathons as a way to learn and prove their capabilities as they become agentic engineers. And oftentimes there's this idea that we work in a void. So we can create almost anything we want at this point relatively easily, but nobody sees it. Right. So one of the benefits to the hackathons that at least these students are doing is they're developing for a purpose. And for example, they did a big Y Combinator hackathon on Friday last week, and they won second place. I don't know why they didn't win first, but second place is great. Good, congrats, guys. But what was great is they were given very confined deliverables. They had to essentially work with these Y Combinator startups and use their tools and create new interesting things with it. And the result was they won a few $1,000s, but they also gained visibility in that space that they were interested in being visible in. When they met the founders of the startups, the guys that were involved in Y Combinator. Now the Y Combinator guys are all excited about having them start some kind of startup. So there's secondary benefit and purpose, I think.
Exactly. It
Yes.
gives a sense
Yeah,
of purpose.
to Ocean's point, that was yeah, that's the crew. Sorry, go ahead.
Ayush. No, it's the purpose, and it's also, it's us having a system to do this on a repetitive basis and to get recognized about it and to become to really have a global impact and to show that global impact. Because if you look at other endeavor out there, they are all working in silos. We have the chance to be global right now, right? How many chapters we have? So it's set up the wheels in motion. That's that, and we start with media, and then we're going to move to tourism. And I saw already I saw a solution in the chat about how we could help protect our mind and attention. That's exactly how we should approach this kind of problems. No, not your simple standard solution of, oh, we're going to create content for you. No, it's that, but we're going to make sure that we also protect your mental space. That is going to be unique on the market. So I'm sure we will come up with amazing ideas like this. That's the idea, really.
Yeah. Yeah. We have to live in a world where corporations exist and are part of our benefactors to make sure that we can continue doing what we do. So I'm excited to help. Am I allowed to contribute to the hackathon, or is that cheating?
We were
Absolutely.
about to just say that because there was an interesting discussion. We said maybe about the reward distribution, right? And we were talking about blockchains, and I was saying like, hey, we got agentic payments and other stuff and other stuff. So there was this. Maybe Vincent, it's worth you mentioning briefly, like this whole point of reward,
Exactly.
distribution, like you got the hypothesis.
Okay, this is a complex topic, this one. So I'm gonna let the expert talk, but long story short, it could be a DAO, a distributed autonomous organization where we are all incentivized through contracts to get rewards and have voting right, So you need to know blockchain and so on and so forth. Is there something simpler? So Robert asked the question, maybe we can use some of the stuff that Roof did and does. I'm like, hell yeah, probably Roof, you could unlock 99% of all the problems with your builds. So I'm sure there is a solution here, and therefore you should contribute for sure. But this topic is going to be one of the main topics of the first hackathon. How do we organize ourselves? How do we distribute the value that we're going to get from this? The DAO came as an option. Maybe there are other options. I just don't know. Open to discussion, to be honest.
Yeah. No, I'd love to contribute any way I can. I build the things I'm building I'm building for the clients generally that I'm working with, and I'm fortunate to have clients that kind of understand me and the fact that I like to share. I don't share everything I build for my clients, obviously. There's proprietary things in there, but the things I learn and discover as part of the work that I do that supports me professionally, I'm lucky enough to be able to share with you, which is something that I would never have been able to do if I was at a large tech company, right? So I've got that's the advantage of being an independent guy. And anyone that doesn't like that probably isn't going to hire me anyway. So, I'm in a unique position, and if we can extend that, all the better. All
Yeah,
right, I see.
we can have teams
Uh,
from around the world.
yeah.
And then Robert E was suggesting that we could invite students from 42 campuses around the world to put together teams. So as the challenge with TV5 gets broken down into different segments, teams can be working on all the different aspects. Just a matter of the orchestration and some kind of user experience. What's the visualization, the touch point between the actual hackathon that's taking place and the teams that are doing the work?
Yeah. All right. Do we have who's up? Are we how are we doing here? Are we have room, we have time for some more demos? What's the plan here?
Anna put his hand up. He says he's got something for us this week. What do you got cooking there, sir?
Sorry, I think you might have broke up slightly.
For me? Or
Yeah, Dre.
oh, there, it's me. Oh, sorry, I didn't hear you. You called my name. So on Monday, I decided to dig deeper and understand better what Lionagi is, and what's the better way to do that than to build something on top of it. So can you see my screen?
Yes.
Okay. So presentation ready? Because I wanted more to show. You can take a look at the code later. But for those that are always wondering how things are being created by other people, not only by Ruv, and as Ruv shares his creation in the Vibe coding sessions on Thursdays, this is like a short story how this emerged just by pointing Claude code and couple of questions. So as I started reading about Lionagi, I cloned the repo in a DevPod workspace, and I asked it, okay, let's try to build a new version of agentic QE fleet using Lionagi as a base, but it was more to see what's the plan and what will okay, I wanted to read and to see what will happen. But guys, half an hour later, it already did initial implementation, just based on the initial prompt. So I already had like 3 agents implemented and a base on which I can build further. And yeah, so this was like, okay. And it even gave me, you can even start immediately with starting the environment. But okay, I didn't expect that, so I wanted to create like a repo out of it and separate it, and then continue developing using original list of QE for my agentic QE fleet. So it started implementing the rest of the testing agents, performance, security, strategic, advanced testing, and so on. And 20 minutes later, that task was also done in Python. And okay, I was, having hard time believing that. So I released my QE fleet on it. Okay, let's check what we really implemented in this, 45 minutes of implementation. And I got quite good results based on the initial implementation. So it was not, bad at all. So to give you like a couple of seconds just to check. So, okay, coverage was, lacking. So some things, test infrastructure was not verified and the security validation was not finished, but core framework was there. So it, model router, memory, orchestrator, fleet. Good. That was that evening. So it was like an hour working on Monday morning. Tuesday morning, okay, let's continue. So there were some, test gaps identified. Let's continue generating tests and improving the coverage. And here is how my test generator created a prompt and what it evaluated in the existing process. So, but this is agentic QE fleet using the Claude Code agents to analyze the Lionagi QE fleet written in Python. And with a couple of more tweaks, I sent the code. So it was not even like, I think 18 hours since I started building it. I sent the first version of code to Ocean, as he was one of the creators of Lionagi, and to do his review if he has some time. And this is what I got. So it looks like initial build went quite fine, and I got some constructive feedback to work on further and to improve. So and I'm really glad that this work, will inspire some additional improvements on Lion AGI, and I noticed some problems. I will probably report an issue directly to Lion AGI because some problems with Anthropic model usages. So OpenAI works perfectly. Yes.
I love it. So and by the way, have I been pronouncing Lion AGI wrong all this time? Is it Lion Agi? I like your pronunciation better.
The creator says AGI.
Creator says AGI. Okay, so Lion AGI. Sorry.
I don't know. Lion Agi sounds like it's almost Japanese or something.
Yeah. Looks like I love Japanese, so that's probably where it came from. And let's say so 22 hours since I started development, I had my first test generator agent generating tests using the Lion AGI QA fleet successfully. So not that time. And then continuing some on yesterday, I continued some additional fixes and some additional scanning of the, with security coverage analyzers in order to make the system even, more robust. And if you're interested into learning more about the Lion AGI quality engineering fleet, I created notebook LM. Thanks again, Monlib, that triggered things. And I also created one for Lion AGI itself. So for those that are having troubles understanding some of the concept, this is like a good starting point to start using it. And both the link to the fleet is shared in the presentation, and I can share the presentation with everybody here in the chat. Any questions?
Yeah, so Dragon, I saw you use hooks, which I'm
Yes.
pleased about. And then what do you use the hook for?
Okay, so let's ask. What do we use?
You're talking
there is
Ryan...
there is a demo. Do you see the?
Yeah, like AGI hook.
Yeah. So give me a second. I will, let the agents execute because this was ready for the demo. So let me, execute the agents and ask, what do we use hooks for?
And don't forget, guys, to star both Lion AGI and Dragon's GitHub repos. We can use all the stars we can get, right? Right, guys?
And okay, as this is done, let me just DSP. Well, that one is working. I did in another term. No. Can you analyze the logs and share the findings? Okay. So monitoring AI model invocations.
Okay.
And Ocean, maybe you can just quickly explain what you're doing with your hooks and how they're supposed to be used.
So hook system, after playing a lot with Cloud Code, I just began to develop hook inside Lineage directly. There are three phases. One is pre-event creation, like before the event got created. For example, an event in Lineage can be API calling, can be a tool calling. It basically means anything that can be invoked and have side effects and change its internal state. That is an event. So in order to provide better observability and then control of the flow, I set up the hooks. So pre-event creation, let's say your data is not great. There might be some prompt injection, and then we have some static logic to check it. And then you can break it right there. And then this event will never get created. And let's say the event successfully got created, and then now it's pre-invocation. We're going to check conditions to see whether or not this event has met the conditions to be triggered. And then similarly, there's a post-invocation. And then so during those phases, you can attach whatever functions you can to it, can use for observability, can also, for example, also have broadcaster inside Language. You can broadcast those logs to everywhere. For example, if you want to do compliance for auditing, you can broadcast to everywhere. The hooks are designed mainly for kind of like a peace of mind, in a way that you can real-time monitor everything, and then you know that there's some dead hard-coded logic that will break the flow and then just halt the system when something not correct going on.
Do do the hooks affect the context window? Like one of the things the hooks do in Claude Code, for example, is they don't output to the context. So they're kind of operating kind of outside of what's operating inside of Claude Code, which is useful for,
That
independent
is
sort of introspection.
the feedback. Actually, the output of the hook get fed back into Cloud Code context. That is actually the case because I've read the log. Uh, and then so in language, I have designed it to be so the pre one cannot be prior to you. So there is only one situation that you can modify the data of the log. It's not my intention to use the hooks to change the context, but you can, for example, there are doing some context injection into the branch itself, and then write that as a function, put into the hook, and then this can still be injected because the hook itself is just a flexible function that gets triggered during this event cycle.
Cool.
Thanks for that.
And
Yeah.
And why I say that Cloud Code hooks trigger, that's how the swarm works. That's how Swarm works when the hooks get put into there, and then Swarm just feedback say like, please continue, etc. And then that's automatically injected.
And here are the results of these 3 agents running on the code base. Of course, integration is the slowest one.
I'm having a little bit. So essentially, you're using. How are you coordinating them? How are you orchestrating them?
There is like an orchestrator, but let me ask how are we orchestrating?
And this is a funny quirk of a lot of the development that I do and it's like, how exactly did you do it? Well, let me ask Claude to explain what I just built. And I know exactly what you're going through. And it's like before I do like a client call, they just got me to build something crazy. I actually spend a lot of time trying to understand what the heck the swarm has just done over the last X amount of time, so I can do an adequate job of explaining it. And then there's like this moment where it like explains it in a way that I just explained it. And I'm like, okay, I actually know what I'm talking about. Sometimes it doesn't actually happen, but it is a funny quirk of swarm-based development.
QE orchestrator, yeah.
Cool. You know what would be interesting for Line AGI actually is to use the hook system in Claude Code with the Line AGI hooks. So it'd be like, hey Claude, can you update the settings.json file to automatically use Line AGI hooks as part of your pre and during post and pre-compact sort of sessions and see what that does. You basically are going to use kind of a line AGI Claude Code integration.
Yeah, so Cloud Code integration is already included into Line AGI. And then so a simple way to do that without without using Cloud Code hooks, that's kind of the whole point. I do not want to use Cloud Code's own internal hook feature. even though that is the only way that you can inject context into it during runtime. I mean, you can simply just break it. If condition trigger start this message again using the resume feature, it's kind of the same thing. So let's say, for example, you ask your Cloud Code to output DSL, domain specific language that you defined, and then you ask them to output it in a code block. And then when you detect such a code block from the output, and then you can break the string, and then you simply evaluate your domain specific language output, get it back to the Cloud Code, and as part of your new user prompt, and then just kind of continue from then on. And that way, without using Cloud Code hooks, you just got a domain specific language interpreter.
I'm not sure I follow why you do that. Like, what's the use case?
That is a good question. The use case would be like token optimization and then speed improvement as well. So a token optimization, let's say, let me show you an example if I may. So I will do a new Cloud Code. No, just ignore all of those. I was cleaning up my cognitions. My cognition is an NCP that I use. So right now I'm running session start prompt. It's gonna load a bunch of my preferences, and then what I want to show is mainly when it's invoking the MCP tool. I want to show you how I make it like invoke it.
So you're using commands, you're not using skills.
I haven't explored Cloud Code skills yet. I don't know. I don't know why I want to. So for example, here is how language or how I make MCP into this. You do not use JSON. I just don't like JSON. I think that just wastes too many tokens. So here you're doing a parallel request over this accountability tool inside of the MCP. You're doing the check-in, daily summary together. And then right now, it's also checking my to-dos. It gets the statistics and then the contextual to-do for the item.
Can you click Control O so we can see what's happening under the covers? All right, scroll up a little bit. Yeah. Oh, I wanted to see your what your MCP request looked like. All right, so let's see here. You've got your smart session. You're starting. You've got the session information. Your
Yeah, have I taken my pills? Have I walked around? What have I done today? It's an ADHD accountability system.
I love it. It's I could use that. Keep going down here. Let's see what else you got here.
And then it checked in, daily summary, and then it did get on stats. Yeah, and then
you should totally use skills for this. What you are essentially invoking the skills by using the commands to do it.
And then it starts to look up, okay, so who is Ocean? And then what are some Ocean's preferences? And then here the fun fact is I make it into a Pythonic invocation structure, so that this is like 1, 2, 3 commands within a single command. And then I make the output look a little bit more compact. All right, so that is how would you do like a domain specific language interpretation. That like a simple effect of that is token optimization by itself. This is a lot less output token. The model doesn't need to do weird JSON. It uses a Pythonic syntax that's a lot more natural.
Okay. So and back to practical application. So I'm creating you used an ADHD example so to keep my mind focused, and I suffer from this pretty badly. You're creating a mechanism that allows both me and the AI to sort of have a kind of shared vision of what's happening. Is that what you're describing?
In a way, so this is my externalization of most of the things I want to know in my head, and I just want to get it out of my head. This follows the get things done methodology. So if you have the idea is if you have all the open loops inside your head to a trusted external system, you will achieve a mind like water and then be the presence and all of that. So the point is just to I know I want to do a lot of things, but I need those to be in a system so I can focus when I need to focus.
I love it. You're applying your way of thinking to your AI. Yeah. Cool. This is really nice work you're doing here, Ocean. I'm glad you're showing it. As you know, I'm a big fan of skills. I would suggest you create some, line AGI specific skills, and then the benefit to the skills for what you're describing right now is rather than manual invocation of the command, which you showed, it does self-discovery in the most simple terms. So when you let your swarm go and you've got all these skills, the agents basically are broadly describing what it needs to do and how it needs to think. And then as part of that, it's got this kind of repertoire of different skills available to it. So you can think in a human element, think of skills like my ability, like in the Matrix movie, I can download the ability to do karate, or I suddenly know how to play the oboe or whatever. And those are skills that can be applied. The cool part of the skills in the Claude Code system is the system can kind of figure out when and where to get those skills. When you have commands, the operator, have to explicitly say use this skill. The agent capability essentially does that at this point, so it's kind of redundant a little bit, right? And what you're describing is perfect because you're already using this kind of conceptual cognitive framework that says, here's how you need to think, here's the information to structure how you're thinking. Now all you need to do is say, here's the library of things you need to do within that. It'd be simple for you to add.
I'll go check it out. Thanks.
Yeah, it's cool stuff.
A reviewer mentioning that sometimes the systems wouldn't always invoke the skills, just sort of skip ahead and run without summoning the specific skill to a task. Has that been? I was experimenting a little bit with the description of the skills. Have you found that that's evolved over time?
Well, similar to what Ocean was describing, what I've done is two-part. One, I've described the skills that are generally available to the agent. So basically, I'm saying here's the sort of secondary skills you can kind of draw from, and the agent can determine when and how to invoke those skills. The next part that I did is I created a sort of vectorized machine learning approach that basically says, here are the skills that I've learned and how to use them over the last X amount of runs. And on a decent development project, there could be tens of thousands of sort of vector entries in the system, which then creates patterns for the system to learn the interconnected relationship of what's been built, how it was built, the problems that it incurred while it was building, like a bad edit or whatever other problems happen. And then it creates secondary skills. So there's primary skills would be the skills within Claude Code that says, generally, here's a prompt and how you need to understand the problem. The secondary skill is basically, here's how I've trained myself to become better at doing these things, much like back to the karate analogy. I got muscle memory. I've done the same moves enough times that I just kind of instinctively know how to do it. Then I invoke those in a way that's faster than the system needs to make the request because I don't want to induce latency. So back to the temporal element, I want it to be able to make the request in milliseconds before it makes the primary request. So if it already knows how to do it, it shouldn't bother going to the LLM and saying, "Hey LLM, how should I do this thing?" It should already basically, I've done this thing 1,000 times before, literally 1,000 times before. I already know how to do it. I'm just gonna use the local vector as the basis of making the response, which saves me money and time on the LLM, which ultimately means I'm not going to run out of usage using Claude, the Claude Pro or whatever they call it. And secondly, if I'm running at scale, I'm not going to pay money for API calls I don't need. It's all which independent. It looks like Ocean has kind of generally done the same thing, which is cool. It's kind of independent validation of we're both working to solve similar problems in different ways.
I think we're all trying to, in a way, migrate away from JSON and JSON, and then that kind of like unnecessary tokens in the input and output. So my way kind of going about it is domain-specific language, and then what I've been trying to phrase it as cognitive programming. So basically, I find the current scheme of using React Loop is very inefficient and then just a little bit silly in a way, wasteful of compute. So I think we'll be seeing much better solutions on how to utilize existing models better in future.
Yeah, and for those who are unfamiliar with React Loop, the early agents use the concepts of, well, it's an acronym of re and act, not the front end framework. And I think a lot of us have moved away from that as well. Like I'm predominantly using ODA loops and things like that rather than React loops. But it really it's like a plug and play. Like some problems work well with React, others work better with ODA, and there's several other sort of loops that you can choose from.
Well, React is exactly what Cloud Code is doing. It's reasoning, actioning, reasoning, actioning. So it's kind of like that. But what I mean is that that mechanism they're doing is inefficient because you're feeding back all of this action result into the Cloud Code before it can do the next action, which is sometimes that is just not the best way to go about it. You will have a bunch of crap context in there that the model doesn't want, you doesn't want there, but it is there. So how can we get rid of those kind of like nonsense context that we don't need from appearing inside of the model? So let the model program and let the model decide what to give it back to itself.
Yeah, makes sense. All right.
Roof, I would like to add something about that. I just built this platform in the past 2 weeks using Agentics, and it's been a fascinating, fun experience. It's like a new way of vibing. And for the size of the files, I run into the same problem using the inefficient React Loop in a sense. And then I was looking for solutions, and I found this token-oriented object notion. It's Toon, Toon. I don't know if you have heard about it.
Yeah, Tune.
Yeah.
It's basically a kind of I don't know, a substructure that removes all the verbosity of JSON. It to me it seems like it's reinventing the wheel a little bit. Like why not just use TOML? Doesn't that do exactly the same thing?
Yeah, I kind of tried both, but I got really good results because I'm on the Cloud Pro version. I kept running into the breakage of the loops, right, of the continuous loop because I don't have enough grades. So, and then I implemented that using Cloud Code. It was fascinating because actually it brings a lot of efficiency and speed to the system. And then when I was running out of crates, then I was using the GLM 4.6 and was actually able to get recent results with the agentic infrastructure going and building the things for. It was really fun. Wanted to share that, guys.
Yeah. If you want, do you want to give a demo? Or
I cannot demo it yet. I have to wait until it passes because I built this for a specific use case. So until it passes that and get an answer from that, I'll be able to demo it, guys.
It's
Problem
fun you
with
mentioned
TOML,
GLM.
Ralph, is that the end of the file is not obvious, unlike with JSON. There's no explicit close signifying the file is complete. The same problem exists with YAML.
Yeah, that's the reason I actually last week I went back to XML, and I'm pretty like happy with the results. I mean, it's
you're like the anti-JSON if you're using XML.
Yes,
like
but the one advantage of like there are 2 advantages of XML, even 3 right now, right? First is when you get the model output, you can always validate and see if it's wrong or not, just because valid XML is valid XML. So if model messed up, you know it immediately. Second, you can mix and match different DAC because it has namespaces. So you can actually throw a bunch of like different tags into document that the downstream things, if they don't know how to handle them, they will just not see them. And the third, with XML, if you do proper encoding, there is no way to mess up. Like like if you proper XML encoding, all the double quotes, everything, it just like passes. Like if you use proper like entity annotations for everything, it will just always like encode any things like. Because what I was working on is the models. I was just giving them like an artifacts. I was giving them JSON markdowns and everything. So you cannot put markdown inside of markdown. It will render like crazy. Like yeah, and XML, it's like there is a clear boundaries everywhere. So it's more verbose, but in hard to read. But it's like I'm so far pleased with the results.
You can nest Markdown. You just need the code block.
Yeah, but code block is not really code block. It doesn't render as correct markdown like it's usually interpreted. And also you cannot nest code block inside of code block.
Are you trying to run two code blocks in that case, or represent an example code block
No, I mean,
syntax?
if you nature of what you're working with is very hierarchical, right? So you can put like an output, markdown output in the code block at one time, right? But if that already contains the code block, that will basically like not, it will mess it up because like it sees like a three quotes and I think it's the end of the code block, and then there is a bunch of like non-code block text and that followed by another code block.
Got a quick question. I've been working on a little project, as you probably are aware, and lots of little projects. And I've been playing with something called Jujitsu. Is anybody familiar with Jujitsu from GitHub?
Yeah, I was curious about it.
Yeah, so I've been I've been looking at, I've been doing a lot of work in the AST and optimization and having collaborative development, multiple agents capable of working on the same code base without blocking. And one of the biggest challenges that we have with Claude Code in particular is the idea of blocking. Agents working on the same code base have a tendency to block each other, especially when working on the same file, right? So oftentimes the agents basically have to work on different parts of the same code base to effectively contribute, and then you're going to see breakage as that happens, right? So there's this project from what called here. Let me actually, I'm sharing the wrong screen. From GitHub called Jujitsu that attempts to solve this problem. You can see the repo called JJ here. And basically, what this is a version control system that basically allows you to get a copy of your code, track changes. And what's interesting about this is it has this idea of a kind of time-based replay, I think is what they're calling it, that allows you to add this kind of recorded work copy commit structure. So as it works, it can learn. You can try different approaches concurrently without blocking everything else. So, and what's cool about this project is it's built in Rust. So, and when you see here, for example, in my implementation, I haven't published this yet. I'm still working on the last bits and pieces. But a lot of the pieces that I've got in place for my agentic flow system already have sort of the core underlying kind of coordination capabilities in place. But what I was struggling with was the ability for those agents to more effectively coordinate the actual development. So in this case, we've got this idea of agent one refactors authentication, agent two updates the database and writes tests and things like that. Now, the interesting part is the part here where we've got, not just 5 agents, but hundreds or potentially thousands of agents that I can point at it. So what I'm really trying to do is go back to the original sort of vision where I'm like, how can I point 1,000 low-cost agents at a problem? And what once took me, 2 hours, I can now do in 2 minutes or maybe, 1 minute kind of approach. So this uses the idea of zero copy operations. It's got this kind of AI first design, operation log tracking, confliction detection, pattern learning, using all the various parts I've built to this point. And I can also run it completely in the browser. So I'm not dependent specifically on the IDE, in this case using VS Code or something similar. And again, compiled it all as a WASM, conflict free. And one of the really cool features is this idea of time travel debugging. So not only can I build an application, I can build 50 versions of the same application all at once and basically say, version 45 is the best of all 50 versions that I've just built all within a moment's notice, and I'm gonna use that. Right now, what's essentially happening is I'm building what I believe to be the optimal version, and then it runs for an hour or two, and it builds me that version. But instead, because now I'm able to do more, concurrent development, I can do them all at the same time, and I can do 50 or 1,000 versions of the same code all at once and throw away the other 999 versions that don't meet the criteria for whatever reason. And I might be sounding like a maniac. I don't know. So that's what I'm thinking, and I think I made it work using jujitsu, which would be cool. Any thoughts, or am I just blabbing here on a Friday afternoon?
So what's the maximum measured concurrency?
Infinite.
Measured
So
concurrency.
there is no limit as far as I can tell. So because
There is a theoretical
I've
limit,
over
but how-
the only limit is essentially how much I can afford to spend on my LLM. Now I remember I'm using Quick for zero latency sort of coordination. I've got my federation components. I've got the ability to automatically detect failure and recovery from different models. I can use, Open Router, Gemini, Onyx for local, whatever. So essentially, there is, as far as I can tell, theoretically, no limit other than my budget.
So the interesting thing, Ruv, what you're saying is if you had to build the world's best piece of software, and if you think of them as six locks side by side, and you're trying to pick six locks in a row, it's almost like if you're to do these things concurrently and you had like the end goal and the out goal, you could actually write the most efficient piece of code as you're trying to compile all six pieces of code. So it's not just attacking one code base, but if you're attacking all six pieces of the code base to get to the best possible outcome, then you're like some kind of, square root of pi as you're trying to figure out the right, most optimal way of running a piece of software.
Building, running, optimizing the software
Yeah.
concurrently, because there's literally I won't say infinite, but there's a lot of different ways to build the same software, right? There's language, there's structure, there's data, all these different variables come into play. The more complex the software, the more variables that exist within the sort of development of that software. So, and one of the challenges that you have in building this software, other than does it work, is did I build it to be the optimal structure, the core structure of the software. So in this case, and the only way you really get to understand the optimal software isn't theoretical. It's not creating an MD file that says, based on all the various approaches, this is the best one, because that's the AI telling you it's the best one. And most times it's just telling you what it thinks you want to hear. The only real way to get to the optimal software is to build it, try it, fix it, optimize it, right? And that's building. So in this scenario, it's basically just building many, many variants of the same to solve the same problem in different ways. Speed,
So
security, whatever.
yeah. So Rob, there is couple of things. So first, Git also like now they have something called work trees. I tried to use them; they confuse me, but it's exactly basically in the Git repository you can make another tree like that. Something can work independently, like, and it just sits in like little subdirectory. And the way I'm routinely run on like my larger projects, 3 or 4 agents at the same time. They work on the same code base, but the whole thing is very modularized. So the agents usually focused on very like small area and everything, and all the communication between modules, it's very tightly controlled. Like there is non-protocol, and that seems to be work. I mean, that's no school, but seems to be work well.
Yeah,
So
the work trees was the inspiration, and I think, if I'm not mistaken, the work trees within GitHub is kind of the first step towards what the jujitsu approach that they're working towards.
From what I understand, they just created subdirectory that's like get ignored, and they just like clone your repo there. Like you can do it as many times as you want, but it doesn't have the Git directory. It links back to your like the main code base. Like they kind of confuse me. Like, but it seems like the Claude recommends them, and I think there was some project called Claudia. It just creates like tons of them, and that's how I was looking at.
Yeah, and it makes a mess. So the key difference, what I'm doing is I'm doing that either in memory. It's transient. I don't care if it writes to the disk itself. Or two, I'm creating ephemeral sandboxes, E2B or whatever, and then building it there and then letting it run and then saying is it good or bad based on whatever parameter. But similar, but more decentralized.
Yeah.
Roof. I kind of run into the same issue because I was trying to run locally a large language model to do certain tasks. And then I thought, I didn't get to do it, but I thought about this idea. Would it make sense to actually have like a proxy outside that combines the results from this many different sources? And then your orchestrator flow or something tests those results from the different models and then comes with a, I guess like the way how you have the way of thinking, the weighted decision making to what is the actually most optimal code based on your test, right? Because I feel like when creating something new, you're also going between vibing the code and then also testing the code itself based on the actual user case you want the actual final code to be, right? So I'm thinking about it, how to combine the different sources into something that can actually orchestrate a result, even if it comes from different sources. You know what I mean?
Yeah, but I think how's it different from pull requests? Like it's from what you describe.
Well, pull request is kind of the merge of data or code within the existing tree structure. So it's similar, I think, conceptually. And I haven't fully got my head around the jujitsu system, to be completely honest, in terms of how it handles consistency or eventual consistency anyway. But I think it's basically a kind of DAG structure that allows you to collaboratively do that without having a kind of atomic merge, which is kind of what a PR is. And I'm maybe grossly simplifying what it's doing, but for me, I've got this ability now to have a federation. So I've got these agents that are floating around doing different tasks. They're all learning from each other. Now I've got the ability not only for them to learn from each other, but to especially build concurrently from each other, but take everything that the random other agents are doing across multiple versions of itself. It's almost like this idea of like parallel universes applied to coding or something, where I've got these parallel versions of the same thing operating, learning, building, and then collectively understanding what they're doing, both specifically but independently. And then at the very end saying, okay, out of all these versions of parallel universes, this is the best possible based on the parameters that I've given it, output, performance, whatever.
If you do concurrently, so the number of your parallel universes, it's exponential, right? So like if you get two, like it's a factorial, right? So like with the 3 agents, you can make 6 universes, right? So with the 4, you're gonna get 24, right? So it grows as a factorial, right? So each agent you add, it's basically a combination of whatever it created with everything else is created. So it just combinatorically explodes very quickly. I mean, and it might be good. You can actually
agent talks to every other agent, right?
No, if they want to combine, like, so if they created like so basically you get like a universe, right? That has a combination of all the agent outputs except one, right? So then another one, there is another combination of because that agent might be messed up, right? So there is one is everybody together, there is another one -1, then there is -2, but then it's all combinations of all agent outputs. That's how many universes they have, and that might be good things because it gives you like a huge space to like basically not optimize to see what's the best, right? If you have objective metric, you can look at all your universes and see like which one performs the best. But just testing it requires not infinite resources, but a lot of resources. Basically, it's like
yeah, and trying to push the boundaries here. I don't know. It might be a dead end. Who knows? But it looks like an interesting project.
It might work because if you have 4 agents, you only get 24 universes, so like that's manageable, like, right?
Well, what's interesting about your sort of idea of exponents here is when you look at at agents and the performance of the agents, they don't generally use a kind of linear approach, right? 5 agents aren't 5 times more effective than 1 agent. They generally are 5 to the exponent of 5, right? So there's this weird sort of quirk where they are much more capable. So looking at that sort of weird quirk, you start to realize that, the combination of a kind of, I'm going to call it the hive mind, which collectively understands what all these various agents are doing using that exponent, and then sharing the bits and pieces of that across 5 agents times 5 other agents and so on.
5 is okay. I think it breaks down. It's the same idea as like how many people you can put on a team or how many computer screens. Because I noticed, and I think you also said, if you get 5 agents, yes, the performance increases dramatically. If you get 20 agents, they're just going to sit in the meetings all the time. They're not doing any work.
Exactly. And that's why this approach solves, I think, if my hypothesis is correct, solves that problem. So suddenly now
to here. Because there was the same math works with the number of
It might work.
the number of computer screens because
No, because I want to see what you're doing while you're
sorry,
You got a hot mic.
Sorry, guys.
Yeah. So it works with number, like when you put another computer screen, the performance doubles. But when you have 24 computer screens, you just go crazy and you can't even like comprehend everything.
You're not looking. You mocking my office here. You guys.
How many you
guys
have?
Can't,
I had
can't really
6 at
see.
one point, and I got. I mean, my neck broke because like looking from left to right, it's like insane.
Well, if you, I've got a 55-inch screen here, but if you include my multi-screen laptop and the other laptop which also has multiple screens, I'm sitting around 11 screens.
Wow, I don't know. My maximum is 3.
Ruth, do you think it would make sense to actually take the thinking behind like a blockchain and use the providence and the tamper evidence if we're actually looking to create a system like that, actually have the multiverse, developing the application, and then at the end comes to consensus to see which one is the best or takes the best pieces out of everybody.
There is so you guys are probably aware in Cloudflow I built a multiple consensus algorithm to do exactly that. But I have my issue with my consensus algorithm is I haven't fully utilized it other than the DAG implementation I did a while back. So I've been looking at ways to improve that. And when I started building the federation system last week, I realized that I finally had a really good use case for my various consensus components. So when you use the hive mind element within Cloudflow, you're seeing the consensus, right? I've got different consensus components. So you get a central sort of a shared, I don't know, conscious structure. I don't even know how you want to describe it. And within that, the different agents are trying to say, based on what we're working on, here's who gets to work on this part. And then, or here's how we decide what and how to solve a different problem. And that creates an internal consensus, right? Once that consensus is reached, agents are spawned, agents do different work, and so on. Now, to Vlad's point, that only gets you to a certain point, and I saw a diminishing return generally somewhere over 10 to 15 agents made no difference, right? And it was just too much to do, or too many agents and not enough to do within that structure, right? Because I was doing a kind of a single problem in single kind of code structure. Suddenly when I'm like, okay, let's do many different independent code structures without conflict, then that becomes less important because they're working together but somewhat independently on different ways to solve the problem. And that's where the consensus becomes interesting, specifically around federation. So I don't know if it's blockchain or just consensus algo. Random opportunities. It's certainly, I don't know where this leads, but it's interesting. What's we got here? Oh, I see Lorraine, you posted the code execution with MCP that they came out with the other day. Let's take a look at
Yeah.
this.
I'd like us to explore that, because I also saw you were looking at this. You're making some changes with the skills, right?
Yeah, excessive token consumption from tools make agents less efficient. This is the feedback I've been getting about Claude Code. When I read this, it's like basically clean up Claude Flow, basically is what I'm seeing here. But your tool definitions overload the context window, right? And anyone you looks at my Flow Nexus says, like, why do you put so much information in there? This is exactly the issue that I was facing. And so what they're basically saying is replace the definitions and only call them as needed, I think.
I'm
Code
still on
execute.
it. I just thought, because one of my feedback was really all the token consumption, and it just seems to be that if we can figure it out properly, it's something that could make a big difference.
Yeah, I agree. And this was also the comment that some of the folks were saying earlier on JSON and whatnot. So what's basically, I think what they're saying, and maybe someone else can explain it better than me, but I think what they're basically saying is don't make your descriptions overly verbose, keep your responses as simple as possible, and use state persistence and skills to invoke what's needed if the skill is invoked versus making it known for all when it's not needed, which is what I have a tendency to do. So there's all these MCP tools that I've made available, and 99% of them you never need to use. So why am I filling the context window with unneeded stuff when really ultimately all you need is the stuff you need at the point in which you're making the request, which speaks back to the skill component. The skills essentially replace the need to explain everything and then only grab the parts that you need explained if and when that part is needed, right? That's the skill versus the command, which is basically you manually telling it what it needs, or the claude.md file, which is here's everything you need to know up front. And I think that's what they're getting at here. Maybe someone else can try to explain it differently than me, but it's interesting.
The way I think we had this discussion yesterday briefly in the live coding session. I think was it Connor? I think Ofer shared some information on this. It's to maintain like a directory, I guess, like not pass the agent files. I think as you were saying within the context window, but like a super agent kind of thing, which knows when to call what. I think that is how I interpreted it.
I
Also,
posted some stuff in there. It's basically like kind of like a hyperlinking approach. You have the top of the system prompt basically has the index, and the tool call navigates, basically searches that index and then navigates to the next layer to extract its next set of prompt, essentially.
What they should be doing, and if you're familiar with MCPs, there's the tools and the resources are essentially the two parts of an MCP server. The tools are the things you invoke, the actions, if you will. The resources are sort of requests that are made to give you more details like textual information. What they should be doing is probably more resources and less tools. So the resources should define the tools and only be requested if and when you need to invoke a tool. So the tools should be minimal, like a name, and then maybe there's a corresponding resource that is requested just before the tool with all the details that you need to understand the tool. But right now, most of that is actually intertwined with the tool description, titles, and other components.
There's actually, I think, a prompt feature. Is there not in MCP? A lot of people talk about the tool discovery and the tool definitions, but there's also a prompt capability of the MCP. Indie DevDan, that YouTube guy, I'll see if I can dig up the the video, but he talks specifically about what he feels is sort of like an overlooked capability or overlooked feature of MCPs. And I think it's like the prompt definition.
I'm not familiar with that one, but it sounds interesting. Just to jump around for a moment, guys, I actually asked I pulled the dragon and asked the system to tell me the difference here between work trees and jujitsu, which is actually giving me an interesting response. Work trees, multiple working directories pointing to different branches of the same repo, which again to Vlad's point, a little confusing. Jiu-Jitsu is fundamentally different via VCS with operational logs, first-class conflicts. So conceptual differences. Work trees look like this. Main Git tree, work tree 1, 2, 3, which are basically folders. And purpose to work on branches simultaneously without switching limitations, still get Git underneath, conflict blocks, no operational log, manual staging. Jiu-Jitsu uses this structure, commit storage, operational log, every action's recorded, current operational state. So it works a little better for this idea of mixing multiple agents. To rethink version control with operation first advantages. So when you look at the feature comparison, which they did here, you've got this idea, multiple working directories, yes, not the focus. This is important because we don't care about directories in an agent structure. We care about conceptual threads, right? Those threads can exist in memory. They can exist in sandboxes. We don't care. Operational log, no, every operation is recorded. Back to learning. Every operation, I'm already doing this. I independently sort of came up with the same solution to the problem without even knowing it. First class conflicts, conflicts are commits, right? Is there a conflict? One of the biggest challenges with Claude Code is it's really hard to figure out where the conflicts exist. And then I'm training the system to try to learn where those conflicts exist. Auto commit working copy, yes. Undo any operation. And anyone that's ever done anything knows that this is probably one of the most important things. I went to I went to the bathroom, came back, and it decided to do a bunch of crazy stuff that I didn't want it to do. And then I got to figure out how to undo all that stuff. This becomes easy. Concurrent edits, one branch per work tree, conflicts are recorded, not blocked. This is also important. So conceptually, it looks this approach, according to Claude anyway, it looks like it might actually be an interesting approach to solve some of the kind of concurrency issues for coding. So if you look at this example, Git tree approach, agent one works on feature A. This is what we're doing essentially right now. Works on feature A, it does commit, so on and so forth. Agent two works on it, does commit. Now, and the issue is conflicts still blocked, blah, blah, blah. Jiu-Jitsu approach just allows for concurrency in a way that's non-blocking. Agents don't block operations. Every change is tracked with full context. Agents work independently, can work on the same files. Conflicts recorded, complete operational log and this is mine, agent DB for learning. So it looks, and I might be getting ahead of myself, but it looks like this might actually be a significant breakthrough in concurrent development. Again, I'm going to publish this over the weekend or maybe early next week. We'll see what this does, but it looks interesting. I'm not going to lie.
Lots of people have their hand up.
Yeah. Sorry, go, Josh. Go ahead. I'm blabbing here.
No, all good. I don't know if Lorraine had a question about what you have. I was going to go back to the discussion previous about blockchain, so I'll let Lorraine go first if she had a question about what you were just talking about.
Thanks, Josh. So there's several things I wanted to talk about. So one of it is I think we need to go back to basics. And the basics I mean is how Git works. So some of these solutions people are coming up with is fundamentally because we don't remember how to use Git properly. So we're coming up with workarounds. And the second thing as well is there's this view of, okay, MCP's got too much information in there, but is it because we are looking at, okay, these open API JSONs and basically implementing them as MCPs rather than thinking what is our app designed to do and only looking at a subset of it. So maybe part of the issues we're having is we're trying to build generalist things rather than be more specific and nuanced in what we are building, rather than going round to solve almost what we call like we're not doing root cause analysis, we're just sticking a sticky plaster on problems. And just some thoughts I'm throwing out there.
Yeah, I totally agree. It's the equivalent is this. Someone looks at a textbook example of how to use the URL lib in Python to make a web request, and they're like, oh, this is too complex. I want to make my library called, fancy URL lib. Wait a minute. No, just become aware of what's out there in the community and use the requests library. That's your fancy wrapper.
I suffer from that. Yes. I'm not built here syndrome or not built by me syndrome. Yeah, I can't argue with that. That's the fundamental flaw of a tinkerer builder is I could just use someone else's library for sure, or I could attempt to rebuild it and understand how it's built just because.
Well, there's also times where you may need, just a couple things out of a library, and do you really want to bring all of that in? That instead of optimizing it to your use case. So, I mean, there is that is an option, right? To build that, especially with the new tools that we have. Yeah. So I don't know if you can let me share my screen or not.
Sure,
I wanted to
yeah.
get back to like the blockchain discussion, and I've been working on this for a little while. I don't have a demo because all you're gonna see is basically just logs, and it's not gonna tell you anything. But what I asked Cloud Code to do is just give me a grounded summary of what this is. So let me just try and share real quick. The screen share. All right, can you see that okay?
Yes.
Okay, so I named it Chrysalids because I wanted to do some I can't even say it, so I don't know why I named it that way. But I named it this because I wanted to do like an evolutionary experimental system using quantum cryptography, blockchain, and basically an immutable tracking of agentic operations. So what I did was I was like, hey, Groove likes, Rust and WASM. Let's go with Rust and WASM and see how this works. So what it does essentially is you have contracts that you post to the blockchain that request capabilities, and then you have agent shells that are basically dumb. They don't have anything but those capabilities. So sort of MCP-ish, right? But not quite. So they may be calling MCP. They may be just having a model, something like that at their disposal to be able to run it against that. But what it does is it creates a secure tunnel between the two after a bidding between different agents for this contract, and then executes that contract and returns that back to the contract holder to fulfill that contract. But this all happens within a tracking within that blockchain to support that communication. It has messaging and receptors for the different capabilities. So contract says, hey, I need these types of capabilities. Agent says, well, I have 2 of these. Does that work for you? And it kind of bits it all out and figures it out. So it's pretty cool. It is running and working, at least on my machine. I do have some more work to do with it, but it's actually really cool.
I love it. You're doing this is like the kind of project I do at 2 o'clock on a Saturday morning.
Right. Yeah, and like especially when you're looking at like service as a software, like that is like the new buzzword type thing, right? Like this is that, right? And this is it in action. So yeah, I'm pleasantly surprised with how good it's working so far, and I'm still testing it out and trying to break it and do all the different things, but it's a lot of fun.
Yeah, the trick now is proof. So run crate to crate, and then benchmark, then optimize. Once you've reached some kind of coherence in the optimization, then create a WASM. Now you're gonna have some performance degradation on the WASM, and
Yeah.
remember that WASMs are inherently have limitations, especially when it comes to like parallelism and other sort of network related access.
Yep.
But you can generally get around that by creating kind of like NPM style scaffolding or whatever.
Yeah.
Then once you've got that in place, then create the NPM package. And then, but the important part of the NPM package, to Lorraine's point, was you don't bother with the MCP first. Start with a CLI. Most everything you need in terms of optimization can be invoked through a CLI. Once you're happy with like kind of the operational context of the CLI and SDK, slap in an MCP, a series of MCP tools to make it easily invoked through Claude Code or whatever.
Yeah.
And then you're done. Publish it. That's
Yeah.
literally my workflow.
Yeah. I think it's going to be pretty cool. And yeah, we'll see how it goes over the next couple of weeks. I'm doing this here and there. I've had like zero time. But we were just talking about that, and I was like, hey, I'll throw this up there and kind of show the world.
Replace the blockchain part with a DAG. Don't bother with the like an actual blockchain. Go with the DAG, and then use the Avalanche consensus algorithm. And then you'll get, or if you want to go super simple, you could use again ED2551 as the kind of pseudo smart contract. And the benefit to that is you'll get like millisecond response on it. The immutability for blockchain is unnecessary unless you want to create some kind of crypto scheme. But other than that, it's gonna be slow and unneeded.
Yeah, I'll think about that. I've just been playing with different ways to make it to build transparency and basically build security through that transparency. So that's what I'm that's why I went the blockchain route to start with. I want, instead of hiding it all, I want it as obvious as possible, but not.
It is
it is
transparent. It's just, but what you're actually looking for is immutability, not
Yeah.
you're right. And the blockchain it's a way to get that immutability, I suppose, but it's just a kind of slow way to do it. So if you want to look at the way I've done similar things, point it at my QDAG repo and just say like examine how I'm doing specifically the DAG component, and you can borrow bits and pieces of that.
Okay. Yeah, I'll do that.
And in fairness, I'm kind of anti-blockchain, but that's a whole other can of worms.
I mean, I think the technology is useful. I just keep trying to find an application for it. So I don't know.
No, it's cool. It's really cool. Nice work there. All right, I gotta jump. I gotta call and I gotta bio break before my next call. Appreciate everyone and their demos. Everyone is 55 people who stuck with us for 2 hours. We're doing some crazy stuff for sure. Thanks everyone. For those in Toronto, we're doing a meetup on Tuesday, November 11th, which I think is next week. So come on down, some pizza. And well, I'm sure there'll be some nice demos at that point. Nolan, are you going?
I'm going to try to. I have a product release that day, so if that goes well, then I'll come down.
Okay. Well, good luck.
Yeah. I want to talk to you about the ARW stuff. I pinged you on WhatsApp.
All right. Yeah, sure. Well, thanks everyone. And Peter, I did push an update just for you for Agentic Flow. Let me know if you're having any more luck with Gemini. It obviously it works for me, but that's my like catchphrase, I guess.
Yeah, I already tested it and it works, but Cloud Code and Gemini go, into a loop. Even with a simple task, it keeps re-editing the file, Cloud Code. using Gemini. So I actually put it in the answer just so you can have a look, but it looks really freaky.
Okay, yeah, reply to the issue and I'll see what I can do. I might have to do more in-depth testing in Gemini.
Right. Okay. Thanks.
All right. Till next week, guys. Thanks.